A sewing machine is a machine used to stitch fabric and other materials together with thread. Sewing machines were invented during the first industrial revolution to decrease the amount of manual sewing work performed in clothing companies. Since the invention of the first working sewing machine, generally considered to have been the work of Englishman Thomas Saint circa 1790, the sewing machine has greatly improved the efficiency and productivity of the clothing industry. Home sewing machines are designed for one person to sew individual items while using a single stitch type. In a modern sewing machine, the fabric easily glides in and out of the machine without the inconvenience of needles and thimbles and other such tools used in hand sewing, automating the process of stitching and saving time. Industrial sewing machines, by contrast to domestic machines, are larger, faster, and more varied in their size, cost, appearance, and task. History. Invention. Charles Frederick Wiesenthal, a German-born engineer working in England, was awarded the first British patent for a mechanical device to aid the art of sewing, in 1755. His invention consisted of a double-pointed needle with an eye at one end. In 1790, the English inventor Thomas Saint invented the first sewing machine design, but he did not successfully advertise or market his invention. His machine was meant to be used on leather and canvas material. It is likely that Saint had a working model, but there is no evidence of one. He was a skilled cabinet maker and his device included many practically functional features: an overhanging arm, a feed mechanism, a vertical needle bar, and a looper. His sewing machine used the chain stitch method, in which the machine uses a single thread to make simple stitches in the fabric. A stitching awl would pierce the material and a forked point rod would carry the thread through the hole where it would be hooked underneath and moved to the next stitching place, where the cycle would be repeated, locking the stitch. Saint's machine was designed to aid the manufacture of various leather goods, including saddles and bridles, but it was also capable of working with canvas, and was used for sewing ship sails. Although his machine was very advanced for the era, the concept would need steady improvement over the coming decades before it could become a practical proposition. In 1804, a sewing machine was built by the Englishmen Thomas Saint and James Henderson, and a machine for embroidering was constructed by John Duncan in Scotland. An Austrian tailor, Joseph Madisberger, began developing his first sewing machine in 1807. He presented his first working machine in 1814. The first practical and widely used sewing machine was invented by Buffer copyright Lemmy Thimonier, a French tailor, in 1829. His machine sewed straight seams using chain stitch like Saint's model, and in 1830 he signed a contract with Auguste Ferrand, a mining engineer, who made the requisite drawings and submitted a patent application. The patent for his machine was issued on July 17, 1830, and in the same year, he opened the first machine-based clothing manufacturing company in the world to create army uniforms for the French army. However, the factory was burned down, reportedly by workers fearful of losing their livelihood following the issuing of the patent. A model of the machine is exhibited at the London Science Museum. The machine is made of wood and uses a barbed needle which passes downward through the cloth to grab the thread and pull it up to form a loop to be locked by the next loop. The first American lock-stitch sewing machine was invented by Walter Hunt in 1832. His machine used an eye-pointed needle carrying the upper thread and a falling shuttle carrying the lower thread. The curved needle moved through the fabric horizontally, leaving the loop as it withdrew. The shuttle passed through the loop, interlocking the thread. The feed let the machine down, requiring the machine to be stopped frequently and reset up. Hunt eventually lost interest in his machine and sold it without bothering to patent it. In 1842, John Greenough patented the first sewing machine in the United States. The British partners Newton and Archibald introduced the eye-pointed needle and the use of two pressing surfaces to keep the pieces of fabric in position, in 1841. The first machine to combine all the disparate elements of the previous half-century of innovation into the modern sewing machine, was the device built by English inventor John Fisher in 1844 for the processing of lace materials. His machine was substantially similar to the devices built by Isaac Merritt Singer and Elias Howe in the following years. However, Due to the botched filing of Fisher's patent at the Patent Office, he did not receive due recognition for the modern sewing machine in the legal disputations of priority between the two Americans. Industrial competition. Elias Howe, born in Spencer, Massachusetts, created his sewing machine in 1845, using a similar method to Fisher's, except that the fabric was held vertically. An important improvement on his machine was to have the needle running away from the point, starting from the eye. After a lengthy stint in England trying to attract interest in his machine, he returned to America to find various people infringing his patent, among them Isaac Merritt Singer. He eventually won a case for patent infringement in 1854 and was awarded the right to claim royalties from the manufacturers using ideas covered by his patent, including Singer. Singer had seen a rotary sewing machine being repaired in a Boston shop. As an engineer, he thought the device was clumsy and decided to design a better one. The machine he designed used a falling shuttle instead of a rotary one. The needle was mounted vertically and included a presser foot to hold the cloth in place. It had a fixed arm to hold the needle and included a basic tensioning system. This machine combined elements of Thimonier's, Hunt's, and Howe's machines. Singer was granted an American patent in 1851 and it was suggested he patent the foot pedal used to power some of his machines. However, the foot pedal had been in use for too long for a patent to be issued. When Howe learned of Singer's machine, he took him to court. Howe won and Singer was forced to pay a lump sum for all machines already produced. Singer then took out a license under Howe's patent and paid him $1.15 per machine. Singer then entered a joint partnership with a lawyer named Edward Clark. They established the first hire purchase scheme to allow people to buy their machines through payments over time. Meanwhile, Allen B. Wilson developed a shuttle that reciprocated in a short arc, which was an improvement over Singer's and Howe's. However, John Bradshaw had patented a similar device and threatened to sue. Wilson decided to try a new method. He went into partnership with Nathaniel Wheeler to produce a machine with a rotary hook instead of a shuttle. This was far quieter and smoother than the other methods, and the Wheeler and Wilson Company produced more machines in the 1850s and 1860s than any other manufacturer. Wilson also invented the four-motion feed mechanism. This is still seen on every machine today. This had a forward, down, back, and up motion, which drew the cloth through in an even and smooth motion. Charles Miller patented the first machine to stitch buttonholes. Through the 1850s, more and more companies were being formed and were trying to sue each other. This triggered a patent thicket known as the sewing machine war. In 1856 the sewing machine combination was formed, consisting of Singer, Howe, Wheeler, Wilson, Grover and Baker. These four companies pooled their patents, meaning that all the other manufacturers had to obtain a license and pay $15 per machine. This lasted until 1877 when the last patent expired. James Edward Allen Gibbs, a farmer from Ruffin in Rockbridge County, Virginia patented the first chain-stitch single-thread sewing machine on June 2, 1857. In partnership with James Wilcox, Gibbs became a principal in Wilcox and Gibbs Sewing Machine Company. Wilcox and Gibbs commercial sewing machines are still used in the 21st century. Spread and maturation. William Jones started making sewing machines in 1859 and in 1860 formed a partnership with Thomas Chadwick. As Chadwick and Jones, they manufactured sewing machines at Ashton-under-Lyne, England until 1863. Their machines used designs from Howe and Wilson produced under license. Thomas Chadwick later joined Bradbury and Company. William Jones opened a factory in Guide Bridge, Manchester in 1869. In 1893 a Jones advertising sheet claimed that this factory was the largest factory in England exclusively making first-class sewing machines. The firm was renamed as the Jones Sewing Machine Company Limited and was later acquired by Brother Industries of Japan, in 1968. Clothing manufacturers were the first sewing machine customers, and used them to produce the first ready-to-wear clothing and shoes. In the 1860s consumers began purchasing them, and the machines are euro ranging in price from £6 to £15 in Britain depending on fiat. Euro became very common in middle-class homes. Owners were much more likely to spend free time with their machines to make and mend clothing for their families than to visit friends, and women's magazines and household guides such as Mrs. Beeton's offered dress patterns and instructions. A sewing machine could produce a man's shirt in about 1 hour, compared to 14½ hours by hand. In 1877 the world's first crochet machine was invented and patented by Joseph M. Miro, then president of what had started in the 1840s as a machine shop to develop specialized machinery for the knitting operations. This crochet machine was the first production overlock sewing machine. The Miro Machine Company went on to become one of the largest American manufacturers of overlock sewing machines, and continues to be a global presence in the 21st century as the last American overlock sewing machine manufacturer. In 1885 Singer patented the Singer Vibrating Shuttles sewing machine, which used Alan B. Wilson's idea for a vibrating shuttle and was a better lock-stitcher than the oscillating shuttles of the time. Millions of the machines, perhaps the world's first really practical sewing machine for domestic use, were produced until finally superseded by rotary shuttle machines in the 20th century. Sewing machines continued being made to roughly the same design, with more lavish decoration appearing until well into the 1900s. The first electric machines were developed by Singer Sewing Company and introduced in 1889. By the end of the First World War, Singer was offering hand, treadle and electric machines for sale. At first the electric machines were standard machines with a motor strapped on the side, but as more homes gained power, they became more popular and the motor was gradually introduced in their casing. Design, stitches. Sewing machines can make a great variety of plain or pattern stitches. Ignoring strictly decorative aspects, over 3 dozen distinct stitch formations are formally recognized by the ISO 4915-1991 standard, involving 1 to 7 separate threads to form the stitch. Plain stitches fall into 4 general categories: chain stitch, lock stitch, overlock, and cover stitch. Chain stitch. Chain stitch was used by early sewing machines and has 2 major drawbacks: the stitch is not self-locking, and if the thread breaks at any point or is not tied at both ends, the whole length of stitching comes out. It is also easily ripped out. The direction of sewing cannot be changed much from one stitch to the next, or the stitching process fails. A better stitch was found in the lock stitch. The chain stitch is still used today in clothing manufacture, though due to its major drawback it is generally paired with an overlock stitch along the same seam. Lock stitch. Lock stitch is the familiar stitch performed by most household sewing machines and most industrial single-needle sewing machines from 2 threads, one passed through a needle and one coming from a bobbin or shuttle. Each thread stays on the same side of the material being sewn, interlacing with the other thread at each needle hole by means of a bobbin driver. As a result, a lock stitch can be formed anywhere on the material being sewn. It does not need to be near an edge. Overlock. Overlock, also known as serging, or serger stitch, can be formed with 1 to 4 threads, 1 or 2 needles, and 1 or 2 loopers. Overlock sewing machines are usually equipped with knives that trim or create the edge immediately in front of the stitch formation. Household and industrial overlock machines are commonly used for garment seams in knit or stretchy fabrics, for garment seams where the fabric is light enough that the seam does not need to be pressed open, and for protecting edges against raveling. Machines using 2 to 4 threads are most common, and frequently one machine can be configured for several varieties of overlock stitch. Overlock machines with 5 or more threads usually make both a chain stitch with 1 needle and 1 looper, and an overlock stitch with the remaining needles and loopers. This combination is known as a safety stitch. A similar machine used for stretch fabrics is called a mock safety. Cover stitch. Cover stitch is formed by 2 or more needles and 1 or 2 loopers. Like lock stitch and chain stitch, cover stitch can be formed anywhere on the material being sewn. One looper manipulates a thread below the material being sewn, forming a bottom cover stitch against the needle threads. An additional looper above the material can form a top cover stitch simultaneously. The needle threads form parallel rows, while the looper threads cross back and forth all the needle rows. Cover stitch is so called because the grid of crossing needle and looper threads covers raw seam edges, much as the overlock stitch does. It is widely used in garment construction, particularly for attaching trims and flat seaming where the raw edges can be finished in the same operation as forming the seam. Zig-Zag Stitch. A zigzag stitch is variant geometry of the lock stitch. It is a back-and-forth stitch used where a straight stitch will not suffice, such as in preventing raveling of a fabric, in stitching stretchable fabrics, and in temporarily joining two work pieces edge to edge. When creating a zigzag stitch, the back-and-forth motion of the sewing machine's needle is controlled by a cam. As the cam rotates, a finger-like follower, connected to the needle bar, rides along the cam and tracks its indentations. As the follower moves in and out, the needle bar is moved from side to side. Very old sewing machines lack this hardware and so cannot natively produce a zigzag stitch, but there are often shank-driven attachments available which enable them to do so. Feed mechanisms. Besides the basic motion of needles, loopers and bobbins, the material being sewn must move so that each cycle of needle motion involves a different part of the material. This motion is known as feed, and sewing machines have almost as many ways of feeding material as they do of forming stitches. For general categories, there are drop feed, needle feed, walking foot, puller, and manual. Often, multiple types of feed are used on the same machine. Besides these general categories, there are also uncommon feed mechanisms used in specific applications like edge joining fur, making seams on caps, and blind stitching. Drop feed. The drop feed mechanism is used by almost all household machines and involves a mechanism below the sewing surface of the machine. When the needle is withdrawn from the material being sewn, a set of feed dogs is pushed up through slots in the machine's surface, then dragged horizontally past the needle. The dogs are serrated to grip the material, and a presser foot is used to keep the material in contact with the dogs. At the end of their horizontal motion, the dogs are lowered again and returned to their original position while the needle makes its next pass through the material. While the needle is in the material, there is no feed action. Almost all household machines and the majority of industrial machines use drop feed. Differential feed is a variation of drop feed with two independent sets of dogs, one before and one after the needle. By changing their relative motions, these sets of dogs can be used to stretch or compress the material in the vicinity of the needle. This is extremely useful when sewing stretchy material, and overlock machines frequently have differential feed. Needle feed. A needle feed, used only in industrial machines, moves the material while the needle is in the material. In fact, the needle may be the primary feeding force. Some implementations of needle feed rock the axis of needle motion back and forth, while other implementations keep the axis vertical while moving it forward and back. In both cases, there is no feed action while the needle is out of the material. Needle feed is often used in conjunction with a modified drop feed, and is very common on industrial two-needle machines. Household machines do not use needle feed as a general rule. Walking foot. A walking foot replaces the stationary presser foot with one that moves along with whatever other feed mechanisms the machine already has. As the walking foot moves, it shifts the workpiece along with it. It is most useful for sewing heavy materials where needle feed is mechanically inadequate, for spongy or cushioned materials where lifting the foot out of contact with the material helps in the feeding action, and for sewing many layers together where a drop feed will cause the lower layers to shift out of position with the upper layers. Puller feed. Some factory machines and a few household machines are set up with an auxiliary puller feed, which grips the material being sewn and pulls it with a force and reliability usually not possible with other types of feed. Puller feeds are seldom built directly into the basic sewing machine. Their action must be synchronized with the needle and feed action built into the machine to avoid damaging the machine. Pullers are also limited to straight seams, or very nearly so. Despite their additional cost and limitations, pulling feeds are very useful when making large heavy items like tents and vehicle covers. Manual feed. A manual feed is used primarily in freehand embroidery, quilting, and shoe repair. With manual feed, the stitch length and direction is controlled entirely by the motion of the material being sewn. Frequently some form of hoop or stabilizing material is used with fabric to keep the material under proper tension and aid in moving it around. Most household machines can be set for manual feed by disengaging the drop feed dogs. Most industrial machines cannot be used for manual feed without actually removing the feed dogs. Needles. Sewing machines use special needles tailored to their needs and to the character of the material being sewn. Industrial versus domestic. Industrial sewing machines are larger, faster, and more varied in their size, cost, appearance, and task. Industrial machines, unlike domestic machines, performing single dedicated task and are capable of long hours of usage and as such have larger moving parts and comparatively much larger motors. Industrial machines are also more generic. A motor for almost any type of machine can work on any brand. An overlocker or a straight stitch machine motors are the same. Sewing feet and bobbins between brands are also interchangeable. However, with domestic machines the motor, and to a lesser extent bobbins and sewing feet, are brand-specific. The motors on industrial machines, as with most of its components, lights, etc., are separate, usually mounted to the underside of the table. Domestic machines have their OEM motors mounted inside the machine. Industrial machines usually have two types of motors: a servo motor, and the more traditional clutch motor. Social impact. Before sewing machines were invented, women spent a large amount of their time on maintaining family clothing. Middle-class housewives, even with the aid of a hired seamstress, would have to spend several days of every month on this task. It would take a seamstress some 14 hours to make a dress shirt for a man. A dress took 10 hours, and a pair of summer pants nearly 3 hours. Most individuals would have only 2 sets of clothing, a work outfit and a Sunday outfit. Sewing machines reduced the time for making a dress shirt to 1 hour 15 minutes, the time to make a dress to an hour, and the time for a pair of summer pants to 38 minutes. This reduced labor resulted in women having a diminished role in household management, and allowed more hours for their own leisure as well as the ability to seek more employment. Industrial use of sewing machines further reduced the burden placed upon housewives, moving clothing production from housewives and seamstresses to large-scale factories. The movement to large-scale factories also resulted in a decrease in the amount of time clothing production took, which caused the prices for clothing to drop significantly. This is because manufacturers were able to decrease the number of workers needed to produce the same amount of clothing, resulting in reduced costs. Increased supply also lowered the cost. The initial effects of sewing machines on workers were both positive and negative, however in the long run the negative effects decreased. Many of the women who had previously been busy at home could now seek employment in factories, increasing the income for their family. This allowed for families to be able to afford more sets of clothing and items than they previously could. For seamstresses, home sewing machines allowed them to produce clothing for the average person during periods when demand for fitted clothes was low, effectively increasing their earnings. When industrial sewing machines initially became popular, many seamstresses working in factories as well as those working at home lost their jobs as it enabled fewer workers could produce the same output. In the long run these now unemployed workers along with thousands of men and children, would eventually be able to gain employment in jobs created as the clothing industry grew. The sewing machine's effects on the clothing industry resulted in major changes for other industries as well. Cotton production needed to increase in order to match the demand of the new clothing factories. As a result, cotton became planted in new areas where it hadn't previously been farmed. Other industries involved in the process benefited as well, such as metal companies who provided for parts of the machines and shippers to move the increased amounts of goods. Gun makers visited clothing factories in order to perfect their own mass production techniques. In addition to being important for clothing production, sewing machines also became important in the manufacturing of furniture with upholstery, curtains and towels, toys, books, and many other products. References. External links: How Sewing Machines Work at How Stuff Works, Sewing Machines, Historical Trade Literature. Smithsonian Institution Libraries. Old Sewing Machines and How They Work in a Euro with Animations, Servant in the House, A Brief History of the Sewing Machine. From the Annual Report of the Smithsonian Institution, 1929, History of Singer Sewing Machines.